This is Algebra Lesson 2-6, Ratios, Rates, and Conversions. A ratio is a comparison of two numbers by division. It can be written three ways. It can be written with a colon, A, colon, B. It can be written with the word 2, A, 2, B, or it can be written as a fraction, A divided by B. They're all read the same way. They just mean A to B. A to B, A to B, A to B, like the comparison of boys to girls in the classroom, or males to females, or people with brown hair versus people with blonde hair. A rate is a ratio of two quantities measured in different units, like words per minute. If I can type 72 words in 6 minutes, okay, that would be a rate. A rate could be like so many miles per hour. I'm driving 55 miles per 1 hour. A unit rate is a rate of a denominator of 1. So 55 miles per hour would be a unit rate as well as being a rate because it's per one thing, 1 hour. If I took my 72 words and I divided them by 6, I would know that I type 12 words per minute, which is not fast. I happen to type over 90 words per minute. Okay, so 12 words per minute. That's a unit rate because it's per one unit, 1 minute, 1 hour, 1 week, 1 shirt, whatever. A conversion factor is a ratio of two equivalent measures in different units. A conversion factor is always equal to 1. So we might say that there are 5,280 feet in 1 mile. That's a conversion factor. Okay, so 5,280 feet is equal to 1 mile. Okay, that's a conversion factor. Or you can say there are 2.54 centimeters is equal to 1 inch. That's also a conversion factor. Whether you write it as a fraction or whether you write it with an equal sign or a colon, it's the same thing. It's still a conversion factor. Unit analysis, or otherwise known as dimensional analysis, is the process of selecting a conversion factor to produce the appropriate units. So if I wanted to convert how many centimeters were in so many inches, or if I had 756 centimeters, how many inches is that? I would use unit analysis to be able to convert from one unit to another unit. Now, you can write ratios and you find unit rates to compare quantities. You can also convert units and rates to solve problems. We're going to be doing a lot of that in this lesson. So it's probably a good idea to make sure that you go through this lesson fairly slowly because this is going to be new to most of you. All right, so Main Street Florist sells 2 dozen roses for $36.90. Flowers to You Florist sells 6 roses for $15. Find the unit rate for each and which florist has the lower cost per rose. Okay, so to find a unit rate when it's dealing with money, anything that's asking you for money, it's always going to be the cost divided by your size, whether that is ounces, pounds, a number like a dozen, 2 dozen, or 15 or 26 or whatever. So we have to figure out the unit rate for two different things. We're going to look at Main Street first. Main Street sells 2 dozen roses for $36.90. So my cost is $36.90. My number is 2 dozen. Remember, a dozen is 12, so 2 times 12 is 24. So it's $36.90 over 24 roses. So if I take my calculator and I plug in $36.90 and I divide that by 24, I'm not going to get a whole number. Okay, I will get a whole number, but I'm not going to get a dollars and cents type of number. I'm going to get 1.5375. Now that's not in dollars and cents. So when that happens, you have to round it to the nearest cent because that's what we're using. We're using money, and you round money to the nearest cent. So this would be approximately equal to $1.54 per rose. Okay. Flowers for You sells 6 roses for $15. So $15 per 6 roses. So if I take my calculator and I divide 15 by 6, I'm going to get a whole number here, $2.50 per rose. Okay, so we found the unit cost for each. This is $1.54 is the unit cost for Main Street for each rose. $2.50 is the unit cost for each rose at Flowers for You. So Main Street has the definite better cost per rose. Lower cost per rose. Now, if they would have just asked who had the lower cost per rose, you could have just done some simple math and gone, okay, 6 is half a dozen, so if I multiply that by 2, that's a dozen. So if I multiply by 4, that's 2 dozen. So multiply 15 times 4, and that's going to be much greater than $36.90. But they specifically asked for the unit cost, so we had to find the unit cost first here. All right. One brand of apple juice costs $1.56 for 48 ounces. Find the unit rate. Remember, it's cost divided by size, so it would be $1.56 divided by 48 ounces. So I'm going to take my $1.56, divide that by 48, and I'm going to get 0.0325. Since we're rounding it to the nearest cent, this is approximately equal to 0.03 cents per ounce. You always have to label per what. It's 3 cents per ounce, not 3 cents per bottle or per jar or per week. It's 3 cents per ounce. And since this is a unit rate, we're going to do it to the nearest cent. Now, if you were comparing and they both would round to the same cent value, then you'd have to go out to the thousandths position to find out which one would be the actual cheaper price. But for the most part, you're always just going to round to the nearest cent. Number 3, in 2000, that was a long time ago, Lance Armstrong completed the 3,630-kilometer Tour de France course in 92.5 hours. By the way, that's a bicycle course. In case you didn't know, Tour de France is the most famous bicycle racing course raced over 21 days, over lots and lots and lots of mountains. They go over the Alps and they go over the Pyrenees, so that's a lot of biking up some very tough mountains. Traveling at his average speed, how long would it take Lance to ride 295 kilometers? Okay, so here, in order to figure this out, we have to figure out what his average speed is because it says traveling at his average speed. Well, his average speed, distance is equal to rate times time. His rate would be what we would call his average speed. So we want to solve this for rate. So if we divide by time, distance divided by time is equal to his rate. So if his distance is 3,630 kilometers, oops, forgot a 3 in there, 3,630 kilometers, and he did it in 92.5 hours. All right, so 3,630 divided by 92.5 says he's averaging about 39.24. I'm going to take it out to the nearest hundredth. 39.24 kilometers per hour. So if he's going 39.24 kilometers per hour, how long? Distance equals rate times time. Okay, so now we need to solve this for time. So we divide by rate, because long is, second part of the question is asking us how long. This is using our literal equations from the last lesson. So time here is going to equal distance divided by rate. The distance is 295 kilometers, and he's going at 39.24 kilometers per hour, so our kilometers will cancel out. So we'll take our 295 and divide that by 39.24, and we will get approximately 7.51. So it's going to take him about 7.5 hours. So there you have using a unit rate to solve a problem, because we had to find his unit rate first, and then once you used his unit rate, you used that value to solve the rest of your problem. Alrighty. To convert from one unit to another, such as feet to inches, you multiply the original unit by a conversion factor that produces the desired unit. It's helpful to know what some of those units are, and I will be giving you the customary system conversion factors for you in class. I'll give it to you as a small piece of paper about the size of an index card or so. It'll be on cardstock, and you can keep it and you can use it for quizzes. The back of your book has some conversion factors for you. I don't remember what page exactly, but it is in the back of the book, and I will point that out in class as well. Some of you know some of your conversion factors, and if you don't know them exactly, sometimes they will give them to you. All right, convert 155 centimeters to meters. Well, the first thing you have to know is you have to know that 100 centimeters is equal to a meter. That is something you should know. If you don't know it, now you do know it. So 100 centimeters is equal to a meter. So 155 centimeters over 1 times, I want to convert it to meters, so I want the centimeters to cancel out. So I'm going to okay, I need centimeters to cancel out, so I know that 1 meter is equal to 100 centimeters. I know that the 100 centimeters has to go on the bottom because of the fact that I need centimeters to cancel out. I wouldn't multiply by 100 because I need the centimeters to cancel out because I want to be left with meters. Okay, so I'm going to take 155 and I'll divide it by 100. So that's because that's going to be my ultimate answer here. 155 divided by 100, which means it's going to be 1.55 meters. So 155 centimeters is 1.55 meters. Number 5, the Space Needle in Seattle, Washington is 605 feet tall. How many meters tall is the building if 1 meter is equal to 3.28 feet? So 605 feet over 1. I always put it over 1. And we're going to multiply that. I need my feet to cancel out. Since I need my feet to cancel out, my 3.28 feet has to be on the bottom of my fraction, and my 1 meter has to be on the top. I know that because in order to get feet to cancel out, one has to be on the top and one has to be on the bottom. And since 605 was always already on the top, I knew that 1 over 3.25 had to be, the 3.25 had to be on the bottom. So I'm taking 605 feet times 1, which is 605, and I'm dividing it by 3.28. So if I take 605 and I divide that by 3.28, I'm going to get approximately 184.45. So I should put my approximately equal to symbols. 184.45 meters. Okay. Some conversion factors will be exact. Some conversion factors you will have to round. And when you do have to round, think logically. Here, nearest hundredth is probably logical enough. You don't have to go out to all the decimal places that your calculator gives you. All right, you can also convert rates. For example, you can convert a speed in miles per hour to feet per second. Because rates compare measures in 2 different units, you must multiply by 2 different conversion factors and change both units. You cannot do these all at the same time. You can't multiply by 1 conversion factor and hope it changes everything. So, the easiest way to explain this to you is to go through an example here. The fastest recorded speed for an eastern gray kangaroo is 40 miles per hour. What is the kangaroo's speed in feet per second? I don't know why the in feet per second didn't go up with speed. Who knows? All right, what is the kangaroo's speed in feet per second? So we have 40 miles per hour, 40 miles in 1 hour. And we have to convert miles to feet, and we have to convert hours to seconds. Okay, so let's convert the miles to feet. Okay, in case you did not know, there are 5,280 feet is equal to 1 mile. Okay, so since I need the miles to cancel out, that 5,280 feet has to be on the bottom of my, on the top of my fraction, so the 1 mile cancels out. So 5,280 feet goes up here. 1 mile goes here. If you write it upside down, you'll notice the things you need to cancel out won't cancel out. My miles wouldn't have canceled out. Then you know you're wrong and you just need to flip your fraction over. So now we've got feet per hour. I need feet per second. So now I need to change my hours to seconds. Well, there are 60 minutes in an hour. So I'm going to say that there's 1 hour is equal to 60 minutes. Now my hours have canceled out. Some of you might have said, but I can convert seconds. I know how many seconds there are in an hour. That's fine. You can do that conversion as well. And I know that there's 60 seconds in a minute. So I know my 60 seconds has to go down here, and my 1 minute has to go up here because I need my minutes to cancel out. So now if I look at this, I have feet on the top and seconds on the bottom is my only label left. So I'm going to take 5,280, and multiply that by 40. So I'm going to multiply straight across the top, and that's going to give me a 211,200. And I'm going to divide that by the bottom, which is 60 times 60, which is 3,600. Okay, so now I have 211,200 feet per 3,600 seconds. I don't need it per 3,600 seconds. I need it per 1 second. So I'm going to take my 211,200, divide that by 3,600, and that's going to give me, okay, I get 58.66666666 repeating. Okay, 0.6 repeating is equal to 2/3. Okay, that's a fraction you should know. If you don't know, now you know it. You need to memorize it. There are certain fractions and decimal conversions you need to memorize. 0.6 repeating is 2/3. So this is going to be 58 and 2/3 feet per second. Okay, that's pretty fast. Okay, 40 miles per hour is pretty fast. 58 feet in a second. That means if you can't run at 40 miles per hour and you're trying to run away from a kangaroo, good luck. It's going to beat you. Alrighty. Let's take a look at number 7 here. A sloth. We did something that was fairly quick. Now we're going to do something that is fairly slow. A sloth travels at 0.15 miles per hour. Convert this speed to feet per minute. Okay, so we've got 0.15 miles in 1 hour. And we need feet per second. So there are 5,280 feet in a mile, so 1 mile has to go on the bottom. 5,280 feet goes on the top because that's the only way we're going to get the miles to cancel out. This is the easiest way. People are like, I don't know if I should multiply or divide. If you do the conversion factor correctly as a fraction, you don't have to worry about that because it'll sort itself out in the end. So I now have feet per hour. I need feet per minute. Okay, so there are 60 minutes in an hour. So 1 hour goes on the top, 60 minutes goes on the bottom. So now my hours have canceled out. So now I have feet per minute, which is what I need. So I'm going to take my 0.15, multiply that by 5,280, and that gives me 792 over 60, but I don't need to know how far it can go in 60 minutes. I need to know how far it can go in 1 minute. So I take my 792 and I divide it by 60, and I'm going to get 13.2. So this would be 13.2 feet per minute. So the sloth doesn't go anywhere near as fast as the kangaroo goes. All right. As a general rule, something to remember to determine whether the number of units will be greater or lesser than what you convert. If you have a number of greater size units and you're trying to go to smaller size units, you should have more smaller size units. If you're going from meters to centimeters, you should have more centimeters than meters. If you have a lot of the number of your smaller size units and you're going to go to a bigger size unit, so if I'm going to go from seconds to hours, okay, I should have smaller number of hours than I did seconds. Okay. So our closure question for today that you're going to put in the bottom of your notes, what type of problem does unit analysis help you solve? What type of problem does unit analysis help you solve?